has been in 1830. Michael Faraday is taken as or considered as father of electrochemistry. He has given many laws and a lot of extensive research is done on electrochemistry. So that you are going to study in class 12. But right now let us discuss here also. He has to say about few things. Let us understand that. So showed that if electricity is passed through a solution of electrolyte, like here I have made a small diagram. You can see here two containers are there. In both the containers one solution is kept. Okay, that solution will be generally a salt solution, and the same salt, like here suppose zinc sulfate and copper sulfate is kept in two beakers. So in zinc sulfate solution we will dip the electrode with the same metal like zinc electrode, and copper sulfate will dip into copper electrode. Externally they are connected with electric wire, and internally the solutions are connected by salt bridge. So like that the circuit will be completed. So when electricity is passed through it, what will happen? Solution of electrolyte, this two electrolytic solution, when electric current is passed, chemical reaction occurs at the electrode. What happens at the chemical reaction? Deposition or liberation is taking place. Okay, so like anode will have oxidation and cathode will have reduction. So like that the processes will take place. Here at one electrode the particles will get deposited, and another electrode it will liberate. So like that the circuit will be completed. So that is studied when the electricity is passed through electrolyte. Now discovery of electron we will study. Discovery of electron in 1850s. Many scientists, mainly Faraday, began to study electric discharge in partially evacuated tubes. There are like cathode ray discharge tube. You can see here there is a picture. Here this tube is called cathode ray discharge tube. Here there is a cathode and anode, and which is connected to high voltage. Okay, so whenever there is a supply of current is passed, what happens? The particles are, the gas is getting charged, the gas which is filled inside is getting charged. Okay, and because of that the particles, the gas particles, you will observe it, there are particles which are going to positively charged plate. It indicates the particles are negatively charged because opposite charges attracts each other. So it is observed. Similarly, it is observed another thing to identify this. There is a small hole is made in anode part, and there fluorescent coating is done, and when again the discharge is passed, it is observed it is glowing. So it indicates the particles will have some kind of significance which is showing with that glow. So let's discuss that how this experiment has been done. Structure of atom was obtained from experiments on the electrical discharge through gases. Okay, the behavior of charged particle, like charge repel each other and unlike charges attract each other. You can see here the opposite charges, here the opposite charges plus and minus, opposite charges will attract and same charges will repel, either plus plus or minus minus, same charges will repel each other and opposite charges attracts each other. On this concept we can observe it, what kind of nature or what kind of charge present on that particle. Correct. So in mid 1850 many scientists like Faraday began to study electrical discharge in partially evacuated tube known as cathode ray tube. Okay, so at cathode ray tube, which is made up of glass, which is containing two thin pieces of metal. Here like electrode at two ends, that two thin pieces of electrodes are present. Then the electrical discharge through the gases could be observed only at low pressure and high voltage. High voltage discharge and the pressure is maintained low pressure. The pressure of different gases could be adjusted by evacuation. Okay, so here what we are observing, there is a glass tube. This tube is called electrical discharge tube. Here there is cathode and here there is anode. These are the metal cathode and anode. anode, and externally it is connected with high voltage, okay, like this. So electrical discharge tube we are studying here. Now when sufficiently high voltage is applied across the electrodes, then what happens? Current flowing through a stream of particles moving in the tube from negative electrode to positive electrode. Negative electrode is called cathode and positive electrode is called anode, okay. So negative electrode to the positive electrode, what it indicates when particles are going to positive electrodes means particles are negatively charged, because just now we have seen opposite charges attracts each other, same charges repels each other, okay. So these were called ray discharge particles, okay. So let's see there. Now the flow of current from cathode to anode was further checked by making a hole in the anode and coating the tube behind it with a fluorescent substance. So striking the zinc sulfide, you can observe it here. Here the anode, the hole is made, and here the coating is done, the fluorescent substance. So what we are observing here, when this ray after passing through anode strike the zinc sulfide is a fluorescent substance, a bright spot on the coating is developed. Bright spot on the coating, here this is a coating, only this area the bright spot is developed. What is the conclusion? Why that bright spot is there are experiment, we can summarize. The conclusion is the cathode ray starts from cathode and move towards the anode. Second is rays themselves are not visible, but their behavior can be observed with the help of certain kind of materials which glow. What is that material? Zinc sulfide towards the anode. When we have coated the, I can show you again, we have coated that particular part with the fluorescent coating, that is zinc sulfide, and by coating that, when the particles are passing through it, it starts glowing. So what it indicates? It indicates the rays are not visible by themselves, but when they are falling, they are observed with the help of certain kind of material which glow, that is zinc sulfide, which is glowing on the falling of that ray, okay. So when hit by the particular rays, then the absence of electrical and magnetic field, these rays travel in straight lines. Whenever magnetic or electric field is not applied or not present, these rays travel in a straight line that we had observed inside the cathode ray tube, correct. So three kind of conclusions, sorry. So the first is the particles are moving towards positive plate, so maybe they are negatively charged. The second conclusion is the particles when fall on the zinc sulfide particular corner towards the anode, so the corner starts glowing. It shows that they are not visible by themselves, but they are able to in the glow we can see them. And the third conclusion is in presence of electrical or magnetic field, these rays always travels in straight line, okay. In the presence of field, what will happen? Electric or magnetic field, the behavior of cathode rays are similar to expected from negatively charged particles. So we are trying to prove about the discovery of electron we are discussing here. So how they are negatively charged. In presence of, see, electrical and magnetic field are perpendicular to each other, which is applied there, and in presence of that it is observed that they are negatively charged particles, okay. So let's see here, the characteristic of cathode rays or electrons do not depend on the material of electrodes and the nature of the gas present, okay, in the cathode. What kind of gas present or what is the mass of that, it does not depend on that, okay. So we can conclude that electrons are the basic constituents of the atoms. Electrons are basic constituents of the atoms, okay. So what we have studied today? We have studied about discovery of electron. First we have studied about Dalton's theory. According to Dalton's, atoms are indivisible. Correct? Discovery of electron in a ray canal tube. When we observed it, what all the things we had observed? The rays, the cathode rays travel in a straight line. Okay. Second is when it falls, it is not visible by itself. Okay. Then particles are going towards positive plate, shows that the particles are negative by nature, shows they are negative, correct, by nature. And last, what we have seen, in presence of electric field and magnetic field, they show they are negatively charged particle. Okay, so like this, the discovery of electron we have studied here. By Michael Faraday started working on it, and we have seen there in a cathode ray tube. Cathode ray tube is a cylindrical glass tube which is connected with two metal electrodes. High voltage is applied, and one side there is a cathode, one side there is an anode, and when the discharge tube electric current is passed, the gas particles gets charged, and because of that the particles start moving. When the particles goes towards, all the particles tries to goes towards the positively charged plate, it indicates the particles are negatively charged. Okay, so thank you.